All right, guys. Today we're going to talk about how to solve rational equations. So this is going to be the first of two videos, the easier of the two. We're going to just go ahead and use cross multiplying today. Okay, use cross multiplying, solve the rational equation, and that'll be pretty straightforward and simple. So our steps today, you're just going to multiply your diagonals. Multiply your diagonals. Then you're going to set them equal to each other. Okay, so multiply your diagonals, set them equal to each other, and then just solve using your standard solving process, thinking back using your inverses. All right, let's do a couple of examples. Again, this is going to be pretty straightforward, simple, I think. So here we have a rational expression. Step one, we said, was multiply your diagonals. So we're going to go 7 times 2x minus 10. And that's going to get set equal to 11 times x minus 2. Okay? So the one place that I see students make a mistake is when they distribute, they only distribute to the first term, not to both. So make sure you do that appropriately. Here we get 14x minus 70, and that's going to equal 11x minus 22. Okay, from here, we're just going to go back into solving this equation. So isolate the variable, and so we're going to go ahead and subtract 11 from both sides. We get 3x minus 70 equals negative 22. Move the 70 over, we get 3x equals 48. Divide both sides by 3, and we get x equals 16. Now, the one thing that we have to make sure of is we cannot divide by 0. That's never allowed. That makes this undefined. And so we just need to mentally check if we plugged 16 in for x, would that create 0 in the denominator? And so on the left-hand side, we have 16 minus 2 is 14, not 0, no problem. 2 times 16 is 32, minus 10, not 0. So no problem at all. So there are no excluded values. There's no values that we can't have for this one related to our solution. Okay? So we would not have been able to have 2, and we would not have been able to have 5 in this case, should those have come out. Those would have been our excluded values. All right, let's do another quick example here. There's only a few of them here, so we'll go pretty quick through them today. So again, cross multiply. We get 3x minus 21, speeding this up a little bit. You guys know how to do this. 10x, and then we're going to go ahead and isolate the variable. So we end up with 7x equals negative 21. X has to be negative 3, and we like to write that as x equals negative 3 first there. All right, does negative 3 cause a problem? Not on the left, not on the right, no problems. Our answer is x equals negative 3. Keeping moving on here, we have another rational equation set up as a proportion. So we're going to cross multiply. So 48 equals x plus 1, x minus 1. That's the difference of squares. So that's going to be x squared minus 1 equals 48. Isolate the variable. We end up with x squared equals 49. And now, make sure you're paying attention, x equals plus or minus 7. All right, whenever you take a square root, you're going to have two answers. You're going to have the positive and the negative. So whenever you take a square root, you need two answers. One of them might later get excluded, but regardless, you need to make sure that you're processing that that is an option. All right, And we don't exclude either the positive or negative 7 in this case, because the only number we can't use would be 1. That's the only excluded value. All right, our last example for this video, right here. So, cross multiply again, we end up with 11x plus 8 equals, and then we end up with x times 2x plus 5. We're going to go ahead, simplify that down a little bit. So 11x plus 8 equals 2x squared plus 5x. In this case, we can't just isolate the variable because we have an x squared term and an x term. So what we're going to do is solve this as a trinomial. So we're going to set this equal to 0. So solve for 0. Okay, so this is slightly different than anything we've done so far. So we end up with 2x squared minus 6x minus 8, just bringing everything over to the right-hand side, set equal to 0. We're going to simplify this the best that we can. Starting off, GCF. Factor out a 2. We end up with x squared minus 3x minus 4. Since we've factored that out, it can actually just go away because it's set equal to 0. 0 divided by 2 is just 0. So that simplifies this when we're solving. Now we're going to go ahead to factor. Two numbers are going to multiply together to give you 4. They add together to give you negative 3. So when we factor that, we end up with x minus 4 and x plus 1. And 0 product property. You set each factor equal to 0. So hopefully this is something you've seen before. That's equal to 0. X plus 1 is equal to 0. And so we solve this. We know that x has to be either 4 or negative 1. In this case, double check that neither solution is one of our excluded values. We cannot have 4 and negative 1 both are fine on the left. 4 and negative 1 are both fine on the right. Neither are excluded values. So when we look at this, all of these were proportions. Cross multiply, isolate the variable, solve for x. Unless it's a trinomial, then you're going to use the 0 product property. In either case, solving these proportions is pretty straightforward, and we just need a little bit more practice. Have a great day.